Welcome to Pivotal Data Showcase. This is going to be a presentation with Frank McKillen talking about regularization in Apache MADlib version 1.10.
This idea of regularization. So regularization is something that you would use to prevent overfitting of data. So here I've shown like a classic example of overfitting, in which we have a number of red data points. We have two curves, a blue curve and a green curve, which fit these points exactly. But you can probably guess which is a better fit to that data. So in this case, we're using perhaps, you might remember from your high school or undergraduate math, if you use too high an order polynomial, and you have using polynomial curve fitting, and you don't have enough data, it will give you a zero error, but that model is not very good, right? So the idea of regularization is to mathematically introduce additional loss terms into your model such that it prevents overfitting. So it sort of penalizes the power of the polynomial or the power of the machine learning in order to reduce the in order to reduce the chance of overfitting. Okay, so there's something called elastic net regularization, and what this does is it implements this in the context of regression, a linear regression on continuous variables. The results are regression, or the categorical variable as a dependent variable. It's a very commonly used algorithm. It exists in MADlib before. What we've added in the last release is grouping and cross-validation. So that's what I want to show you. So we're going to load. So we're going to create a data set here, a toy data set. This data set is pricing of houses. So there's a bunch of features. Here's the price of the house. This is what we want to estimate. The features or the independent variables are things like property tax, number of bedrooms, number of bathrooms, size of the house, size of the lot, and zip code. So so let me train the model. Let's start it running. This takes about 30-35 seconds to train. You can see that there's quite a number of parameters here. So elastic net is one of the most commonly used algorithms for regression, but it's also, I think, one of the more complicated ones just to use because there's a lot of knobs that you have to set. And if you set them wrong, you can get overfitting of your data, you can get underfitting of your data even, or you maybe won't address the root cause of overfitting that you're using it for in the first place. Okay, so this did finish. So what we get here is we get a model which uses property tax, number of bathrooms, and then size of the house. And we've built that model. Then once we've built that model, then we can do what we call prediction, which is like feed it some other data and then predict the price. So that's what I've done here. So for every training training function within MADlib, there's a corresponding prediction function, right? So we're doing prediction. And this is showing residual is just a difference between the actual price and the predicted price, right? So this is showing, hey, we've got a model. So we had that in there before, but now what we added is grouping. So what we want to do now is we want to group on zip code. So this is actually something that's really useful in SQL-based machine learning is to do grouping because you can, in a single call, build multiple models for whatever columns it is that you want to group by. So this is a popular thing that's in many MADlib algorithms. It wasn't actually in elastic net. So let's run this now. I have 2 zip codes, so it's going to take roughly a minute. but yeah, so right, so we'll let this, oh, it's actually came back quickly. So what we see here is for, now we have two different models. We have one for 94301 and one for 76010. And I can then do a prediction function in the same way. And if I do a prediction function, then I get, I didn't put the zip code here, but I got perhaps a more accurate model, which represents pricing per zip code. Right? And you can imagine in house prices, there's a lot of variation within zip codes or groups of zip codes. So this is something that is very useful for data science to do rather than running on for loop around it.
You have been watching Pivotal Data Showcase. For more interesting videos using Greenplum to do data science and big data processing, check out the Greenplum YouTube channel.